YouTubers, and welcome back to the MRC channel. We are here today with our first video coming out in the mini-series on basically how to modify cars, and maybe talking about the Supra here and there, but this is more general knowledge today. So we're going to be talking about fuel systems and how to plan and how to correctly build them. So as we start getting more videos along, you'll have a better idea of the overall picture on how to modify things, but you're going to find out that it's a system. Everything's a system and everything has to work together. So, you got to have the right supporting mods for everything that you're doing. You can't really get away with putting a lot of money in one area and nothing in the other. It's all got to kind of work together. So as I learn YouTube and editing better as well, I will try to add some title slides into this stuff so that you can get a visual of what we talked about and some numbers and some things on there instead of having to just listen to me blabber on about it. So first things first, when you start to modify a car, the fuel system is a big part of it. No matter what, if you're trying to modify for more power, you're going to need more fuel. So the fuel system is one of those things where I feel like a lot of people skimp on and don't do correctly, and they end up running into problems when they get on the dyno. It happens more times than not. And so we're going to kind of go over the right way to do this. And one thing about fuel systems is you can actually save some money in some spots that you can upgrade easily later. And there's some other parts of fuel systems that you kind of want to do it right the first time for future use. So first things before you start to modify a car at all, especially the fuel system, because a factory fuel system will go quite a ways. But if you're planning on making some real power, you're going to have to start replacing some of the fuel system components like fuel lines and things. And so you have to have a realistic goal. That's your first step, is to come up with a realistic goal for the car. How much power do you want to make? And what kind of fuel are you going to run? And basically, what are you trying to make now? And is it possible that later you might want to make more? So some of these things you might want to overbuild right away. And we'll go over that in a second. So number one, I think we're going to start out with injectors. So I got two injectors here, and you can see that they're a little bit different. This one's a little bit thicker, and this one's a little bit thinner. Now, there are two types of injectors. You have a low impedance and a high impedance injector. Now, the way you can tell the difference between the two is sometimes by the size, but not always. But the high impedance injector measured out with an ohm meter is going to read somewhere around 10, 11, 12 ohms. Whereas this one, the low impedance, is going to read somewhere lower, about 3 to 4 ohms. So you can't interchange them most of the time just directly. If you go from a high impedance to a low impedance, you have to actually add a resistor pack or use software in the ECU to control it differently. So what's nice about the high impedance injector is that you can use direct current to control this on and off, and you don't need any type of algorithms to help open and close it correctly. They can handle full current and they won't burn out. So they are a little bit easier to use in that regard, that you can use it with pretty much any engine management system out there without any modifications. So it's a good injector. They've gotten a lot better over the years now with faster response times and everything. But the disadvantage, and you'll find out when we start talking about the low impedance injector, is sometimes you can run into a situation where you can't actually, at high RPM, you can't get it opened and closed fast enough. So the low impedance injector, what makes that special is it usually uses a peak and hold style of controlling the injector. So what that refers to is it takes more current to open the injector, and then it drops the current down to a smaller level to sustain it being open, and then it will close the current and it will close the injector. Now, it takes some pretty precise software to control this. It takes pretty precise electronics as well. And so it's opening it for microseconds, really. So what's nice about that is, as the current falls away, once the injector is open, there's less current being held within the coil on the inside. So when you turn it off, you'll typically get a quicker closing time. And what that allows you to do is run at higher RPM and maintain more control over your fuel flow at that higher RPM. where you'll run into trouble with these. Now, you'll probably notice that on like a Mitsubishi, any Mitsubishi engine, or Subarus, or some Subarus, and a lot of vehicles like that, you're going to see these injectors, the low impedance. Are they using peak and hold circuitry? No, they usually are not. They're actually using a resistor pack. So for each injector, you need to have a resistor that brings the ohms up to that 10, 11, 12, 13 ohms region, so that you don't burn out the injector. If you put one of these on without a resistor pack and no peak and hold driver, you are going to burn these out very fast, and they are not going to work correctly. So sizing comes into play as well, because you might be intrigued to go big right away. And nowadays you can get some really, really, really large injectors. Now they've gotten much better to the point where you can idle a very high horsepower engine with a big injector, but you are going to start losing control, and you're going to lose the linear fuel delivering capabilities of the injector. So that's something you need to keep in mind, is that going big is not always going to be better. You may find that on some larger engines, or making a lot of power, you may need to run 2 injectors per cylinder. And you're going to run a smaller one that controls idle and cruising, and then you're going to have a second set that kicks in under boost and provides the additional fuel you need to keep the engine happy. So there is a minimum opening time for a fuel injector. It gets down to around 1 millisecond usually. On some of these bigger injectors, could be a little more than that, could be 1.5 even possibly milliseconds. So you're going to find that if you go with a really large injector, you may be trying to get it to idle and get the air-fuel ratios right at idle, and you can't, because you can't go below that, because you lose the correct opening properties of the injector, and you're going to either run really rich or really lean and nothing in between. So it can get very interesting. So you also have to keep in mind with injectors that the type of fuel you use has an effect as well, because some injectors are not rated for some of the fuels out there, the racing fuels. So you may need to select an injector based on the type of fuel you're going to use. Now, Injector Dynamics, most of their injectors are rated for these different fuels that have all these chemicals in them. So just something you want to keep in mind when you're selecting an injector. Now we're going to move on to like fuel pressure, because that's something that some people misunderstand. Most vehicles that you're going to be modifying, including the Supra and a lot of return type fuel systems, are going to run 43.5 fuel pressure at static. Now that means that the engine is not running, or there is zero pressure in the manifold. So when you're at zero pressure and you've got 43.5 psi of fuel pressure, the ECU knows this, and that's how it calculates fuel flow. So if you start to change the fuel pressure to get more out of your injector, which you can do, your ECU no longer knows the correct flow pattern of that injector, and when you raise that fuel pressure. So nowadays you can usually set that and change things, and if you start with something, a new car, and you plan to go up with the fuel pressure anyway, it's a good idea just to start there. Now you have to understand too that keeping the pressure at the that same 43.5 or 60 or whatever you decide to run your base pressure at, you need to keep that pressure differential the same on both sides of the injector at all times. So that means you need to have a rising rate fuel pressure regulator, which will raise fuel pressure 1 psi for every pound of boost. Now what that does is it keeps the fuel pressure on top and the manifold pressure on the bottom. The difference is always going to be your base fuel pressure. So if you set your base fuel pressure at 60 psi, you need to make sure that that's maintaining no matter what happens. When the engine is on vacuum, it's going to pull some fuel pressure away to maintain 60 psi. And if you are, say, running 30 pounds of boost, you're actually going to need 90 psi in your main fuel feed line and on top of this injector to keep the flow rate what you tell the ECU it is. Now most injectors are rated at that 43.5 psi. However, some better injector companies will give you a flow rate that goes beyond that pressure. Now, if you get too high with the pressure, the injector is not going to want to open and it's not going to want to close the same. So you don't want to get too high. Typically, you start getting above 85 psi. Some injectors can handle more, but 75 is the max that you should run your base fuel pressure at, because it just starts to run into issues, and it's just a good idea to keep those numbers as low as you can, and we'll talk about why that's important for the fuel pump here in a second. So that's it on fuel injectors. Now moving on to the pump, we just got done talking about pressures, and that affects the fuel pump quite heavily. A fuel pump is rated to flow at a certain pressure, and as you raise that pressure, you lose flow. So even though the pump may be able to still create some of the pressure, you are going to start losing flow, and the pressure will drop. And pumps are usually rated at that 43.5 psi. A lot of pumps will go past that on their charts. That'll show you how much they flow. Now you need to also decide which kind of fuel you're running, because methanol, for instance, you need twice as much fuel as gasoline to make the same amount of horsepower. Now it's possible to make more power total on that fuel, but you're going to need a heck of a lot more of it to do the same thing. So with that being said, you need to choose your fuel pumps based on the fuel you're going to be running first and foremost, because you can't, alcohol is going to be hard on a pump that's not made for alcohol. It'll still work, it just may not last as long. You can also run, 2 pumps, 3 pumps sometimes, or 1 pump. You can run one big one, but it still may not be enough. There's 2 types of fuel pumps, internal and external. So internal would be an in-tank pump, which are much, much quieter. They typically stay a little cooler, so they can run a little bit harder and last longer that way. And the only bad part to that is it can get pretty expensive or interesting to fit enough pumps on a hanger assembly on a factory fuel system. So you may need to go to a fuel cell and run a fuel surge tank, which is a device that essentially captures fuel from the fuel tank by different means, like the return line or things like that, to always keep your main fuel pumps supplied with fuel. That can add a lot of cost, and they do sell external fuel slosh tanks, but you're going to be talking about adding a lot of money to that. So one thing you can do is add more pumps if you're in the future and want to look for some more power. So you can get away with getting the car running on 1 pump, and if you run out or know that you're going to be, let's say, putting a bigger turbo on and you need more fuel, you can always add a second pump to that. How easy that is just depending on your system. If you buy a pump to replace the factory one in the stock fuel tank, you won't be able to add a second one to that. You might have to buy a different hanger assembly. Some guys will run both and run an in-tank and an external fuel pump, and that's essentially a booster pump. But again, the external pumps are very loud, and on a street car, they get pretty annoying. I'm just going to say it right now. It depends on how big you go, too. So the wiring on a fuel pump is extremely important. You want to have the biggest wire you can possibly run to a fuel pump, because they do draw a lot of power when the pressure starts going up, when the boost rises. Because remember, a rising rate fuel pressure regulator is going to raise that main pressure up as boost goes up. The fuel pump sees that. So you want to make sure that you got enough power going to that pump. And a lot of probably the easiest way to do that is to use a relay to run heavy gauge wire from the battery straight to that fuel pump and have that relay being controlled by the ECU. So a lot of times on a factory car, the fuel pump wire that's feeding the fuel pump power that's controlled by the ECU, you can usually use that to control a relay and send more power to that fuel pump. And we're talking along the lines of over 20 amps with some of these fuel pumps, and if you have 2 of them, you're talking about a lot of amperage draw from your battery and your alternator. So with all the other electronics on a car, you need to also make sure that you have the alternator capable of handling this additional horsepower. So now we're going to move on to fuel lines, and that's a controversial issue, or something I see a lot of people doing wrong. A lot of people run a big feed line and a small return line. This is an issue because you're assuming that your injectors are using a lot of that fuel up, because when that fuel pump is running and the engine's not, it has to return all the fuel that runs through the feed line has to come through the return line. So if you're running a -8 feed line and a -6 return line, that is a restriction now. And a lot of times you won't notice it on one pump because you're still able to flow that dash 6 line enough so that you don't create fuel pressure issues. But if you add a second fuel pump, if your fuel pressure regulator is not up to the task of running enough fuel through it, or let's say on the other end of it, on your return line, it's only a dash 6 and you've got a dash 8 feed, which is enough for around 1,000 horsepower on E85, you may get a false fuel pressure reading. It's going to be higher because even though you have your fuel pressure set lower than that, this causes a restriction, the small line does, and it's going to raise your fuel pressure when you don't want to. Like for instance, when that second pump kicks in. So you should always try to run the same size return line as the feed line, because at, like, let's say idle, your injectors are not hardly using any fuel. So any fuel that's coming out of that fuel pump has to be pumped right back to the tank, and it can create issues, especially later on when you want to add a second pump. So that's one of those areas where you should spend the money on right away and do it correctly, are fuel lines. Make sure they're big enough for your future goals. You can't really go too big. I mean, you can, but you're going to use some of that volume up on your pump that it may not make up that volume in that bigger line as easily, and you'll lose a little bit of fuel flow capacity. But most guys are going to be okay with a dash 8 feed and return line. Now, like I said, I'm not saying you can't use a dash 6 return. You can. It will work. But you may run into an issue later, and you don't want to have to tear all those fuel lines back out again once you've already got them all perfectly set up in the car and plumbed in there. So that's kind of the thing with the fuel lines, is make sure you're big enough for future use and future fuels, and make sure that the return is big enough so that you don't cause false fuel pressure readings. And then there's obviously stainless steel and nylon braided hose. The stainless steel stuff handles temperature and pressure and wear better, but it's heavier, and it can actually wear other things out, because that stainless steel, if it's rubbing on something, can kind of screw some things up. So something you want to keep in your mind. The fuel pressure regulator, this runs after your fuel rail. So this runs after the feed line. Your injector should be in front of this. Don't run it after this. This does not go between the pump and the injectors. This goes after the injectors. So if you're doing a custom setup, that's why it has to work that way, because this creates the pressure in the rail. Now, if you're using a factory, or let's say you turbocharge a factory car that has a fuel pressure regulator on it, that has to, but it's not going to be a rising rate fuel pressure regulator. So as you add a turbo, you're going to start losing fuel pressure, that difference between the top and bottom of the injector, and you're going to end up with not enough fuel. You're going to lean out. Or if you get enough boost in it, that fuel injector will actually stop flowing completely. It'll just shut off. It'll open up and no fuel will flow. If you run 43.5 psi fuel pressure, and let's say you've got something that can run 45 pounds of boost, it'll actually start pushing air back up into that fuel injector. And that's not good. You're going to blow some shit up doing that. So we don't want to do that. So the fuel pressure regulator needs to be boost referenced if you're adding a turbo, and it needs to be up to the task of returning enough fuel back to the fuel tank if you run a bigger pump. A lot of times the factory fuel pressure regulator is not going to work for that scenario. So fittings for a lot of these fuel systems are ORB, or O-ring Boss. So you need to know that whatever you're buying, like a fuel rail or a fuel pressure regulator, they're probably going to take these. Probably. Some may be different. Not all of them are the same. But these are a nice way to seal up any threaded holes that need to be converted to an AN fitting. So you always want to make sure that your fittings are compatible with whatever you're using, or obviously you are going to have leaks. So that's kind of it on fuel system. If you have any questions, please comment down below, and I will try to get to them and answer them as I can. But I hope you enjoyed this video. It's a lot of information, but it's basically everything you need to know, the basics on fuel injectors and fuel pumps and fuel lines and fuel pressure regulators. So I hope you enjoyed it, and we will talk soon. Thank you all for watching. Have a good one.